right, let's go over problems number 10 through 16 on the true-false section. Number 10 says there exists a function f such that the function is negative or below the x-axis, always decreasing, and always concave up for all x. Well, let's talk about a function that is always decreasing and always concave up. That function has got to look something like this, and there is no way that you can contain it completely underneath the x-axis, because at some point it will have to cross through the x-axis, and the end behavior as x goes to negative infinity will be that f of x goes to positive infinity. So this one will be false because this is not possible. Number 11 says if f and g are increasing, then f plus g is increasing. And this is true based on just properties of differentiation. So we're basically saying that f prime is greater than 0 and g prime is greater than 0 because f and g are both increasing. So f plus g differentiates to f prime plus g prime. And if each of these components is greater than 0, then the sum is greater than 0. So this is true. Next problem, if f and g are increasing, then f minus g is increasing. Okay, so once again, f prime is greater than 0 and g prime is greater than 0. And the question is f prime minus g prime, how is that compared to 0? Is it greater than 0? And the reality is we don't know, because if f prime is larger than g prime, then yes, there's the bell, I'm at school. If f prime is greater than g prime, then f minus g is increasing. But if g prime is greater than f prime, then f minus g is decreasing. So this one is false. For 13, it says if f and g are increasing on an interval, then f times g is increasing. Well, let's differentiate f times g with the product rule to get f prime g plus g prime f. And we know that f prime and g prime are greater than 0 because f and g are both increasing. But actually, we have no idea whether g is positive or negative and whether f is positive or negative. So we don't know if f times g is increasing. F and g are both positive and increasing. Well, this actually goes right back to what we did up in number 13, because they're asking us if f times g is increasing. And now with the product rule, we know that f prime is positive, we know that g prime is positive, and now we're told that f and g are both positive. So all four of these elements will be positive, and the entire function f times g will be positive. Will be increasing because the derivative is positive. And then last, for number 15, if f is increasing and f is positive, then g equals 1 divided by f is decreasing. So this one will entail the use of the quotient rule to get g prime. So we will have low times d high minus high times d low squaring the bottom. That's going to be an f squared down there. So the first term here, f times 0, goes away by the zero product property, and then this says minus 1 times f prime. F is increasing, which means that f prime is greater than 0. So this is actually a negative value up top, and anything squared is positive. So this is a negative in total, which means that g prime is less than 0, and in fact, g must be decreasing, so this statement is true.